Hello everyone. So today I would like to introduce uh, some of my work to predict the personal equality index. Um, at first, let's look at the dataset. The dataset provided by the organizer is public weather data provided by 26 weather stations uh, surrounding the Tokyo area, and the data is and the data is mainly in March uh, 2019, and it's the hourly data. So my approach is pretty simple. Um, I mainly use the inverse distance weighted uh, to predict um, the value for some unknown points. So at first, I will gather on the coordinates of unknown points that need to be predicted, and then I will use the inverse distance weighted formula to find the value of the unknown point. Uh, and the next step, I will try to use the training data to find the optimized p-value so that I can use those p-value to predict the testing data. So after applying this approach, I find that the prediction for the PM2 is pretty good, but for the NO2 and the O3 is not good. Because I think that there could be uh, there could be a big difference between the data provided by public weather data and the data uh, generated by the personal sensor. And because the inverse distance weighted formula, they don't have any offset parameter or any regularization parameter. So that's why it doesn't have any uh, way to make up for those big difference. So so in the future, I think if we can combine the inverse distance weighted with some regression model, we can uh, improve the results. And I think if we can also uh, take the advantage of the wind direct as some other weather data like wind direction, wind speed, or temperature, I think the result will be better. So I think that's all.